So the big theme of this kind of section is solving for x in different ways, whatever way possible. So let's look at a couple different ways. On card 9A, we've got this negative 1/2 times the quantity x minus 3 squared equals 32. You can't get in there, folks. You have to move this thing by doing something else. Dividing by 1/2 is kind of a tricky process. But what if I multiply by the reciprocal? And that would be a negative 2 over 1. The reason you multiply by the reciprocal of a fraction is because the numerators and the denominators cancel, but so will the negatives. Okay, I just got to remember what I just did. I multiplied by negative 2 over 1. All that's gone. That leaves me with this x minus 3 squared equals. Now that becomes bigger. So oftentimes we look at it 1/2 and we want to take half of 32, which is 16. You don't want to do that. You want to multiply by the reciprocal, so that's multiplying by 2, gives you negative 64. Okay, it's now that we can't add 3 yet. We'd like to add 3, but that thing's kind of hindering us. So we want to take the square root of both sides. X minus 3 is equal to, and you take the square root of a negative, it's an 8 and an I. And it's a plus or minus. Anytime you solve for x by taking the square root, you have to consider the positive and the negative. All right? We add 3 to both sides and we're done. We have x equals 3 plus or minus 8i. Right? Now we also have this other equation here, this square root one, which is kind of the opposite. Here's b. And I've got 3 times the quantity, or the square root of the quantity, 2x plus 5. I got a minus 1 outside, and it's equal to 20. All right. Step by step, we got to move stuff to the other side. Whatever's the most loosely connected, we move that first. So if I add 1, there's my 21. Okay, that's gone. But this 3 out here is in front. So if I divide by 3 now, I'm down to 7. But what I have left here, I got to kind of clean this up a little bit. I got a 20, what? I've got a 2x plus 5, and it's equal to whatever 21 divided by 3 is. That's a 7. There it is, sorry about that. So now, the opposite of what we had over here, I have a square root instead of a square. The opposite, I can't subtract that 5 yet. People don't even try. I have to get rid of this radical, and the opposite of a square root is a square. So I'm going to take the 2x plus 5, which is now released of its radical, but over yonder here, it becomes a 49. The squaring got rid of the radical, but the other side of it had to be that we squared the 7 on both sides. Okay. So now we subtract 5 from both sides. Now that we can, because it's released, I have a 44 divided by 2, and I have x equals 22.